Hi everyone. So in today's lecture we will see about the literals in Java. Today's topic is to know what is called as literals. So basically literal is a constant. Okay? A constant value which can be assigned to the variable is called literal. Or you can say in a simple word that literal is just a constant. Is it fine? Okay. Now let's see. For example, this 10 is a literal, 20.4 is a literal, false is a literal, this Naveen in double quotes is a literal, in single quotes this n is there, it is also a literal. Which type of literals we will discuss this thing. For now just remember the things. These are few examples of literals. Fine. It means what? Literals is a value that is stored into variable. So let me take one example and let's understand the concept. So here we have int x is equal to 10. What is this x? This x is a variable, right? This x is what? Variable. And this int is what? Data type, right? It means this x is of int type. This variable x is of which type? Int type. And this 10 is a value. It is a value which we are storing in this x variable. It means, see, simple thing. Variable is nothing but a container. So this x is pointing to one container in which we are storing this 10 value. And this container is of which type? Int type, means integer type, right? Let's see. So this int defines what here? Data type. It means data type of a variable is what? Int type. X is what? Name of the variable. And 10 is what? A constant value or the literal that we are assigning to this x variable. We are assigning to this x variable. Hope it is clear, right? It means literal is a value that is stored into any variable. That's what we see just right now. Now, now we will cover means category wise. For example, we have first integral literal. Integral literal means what? All integer type literals are called integral literals. Fine. All integer type literals are called what? Integral literals. So the first thing that you should know is how can we specify integral literals value. We can specify in four forms. What are that four forms to specify integral values? Decimal form, octal form, hexadecimal form, and binary form. Fine. Let me cover this one by one. So first in decimal form. Decimal means what? Base 10. Decimal means base 10. And allowed digits are what? 0 to 9. For example, this int x is equal to 10. It is in here, this 10 is in what form? It is in decimal form. Decimal form. Fine. Whatever we have seen, right, means previously, or whatever we will see next is also by default everything is what? This type, decimal representation only. For example, we have seen example like int x is equal to 20 or 30. This all are what? Decimal. All are what? In decimal forms, whatever we see till now. Now the next form is what? Octal form. Octal form means base 8. So allowed digits are what? 0 to 7. In this case the literal should be prefixed with 0. In this case the literal should be prefixed with 0. The same 10 I want to write in which form? Octal form. How can I write? See, example 0 1 0. So see, this 0, I have added 1 0. It means now this thing is what? In octal form. Octal form. Is it fine? So how can you make this 10 in octal form? Simply by prefixing this 10 with 0. Now it is in octal form. So in this case, the literal should be prefixed with 0. Now the next form is what? Hexadecimal form. So talking about the hexadecimal form, allowed digits are what? 0 to 9, 0 to 9 and A to F. Fine. The literal should be prefixed with 0x. Okay. For extra digits, that is A to F, we can use both lowercase and uppercase. You can use either small a or capital A, small b or capital B, no problem. Okay, small f or capital F. Okay, both are same, both are same. Fine. For example, same 10 I have represented here in the form of what? Hexadecimal form. By prefixing this with what? 0x. So it is in what form now? Hexadecimal hexadecimal form. Hope this much is clear. You have to just take care of the prefix things. For example, here the prefix is what? 0x. In the octal case, it was just 0. And the next the fourth representation is in what form? What form? Binary form. Binary means what? Base 2. It got introduced in what? From Java 7. It was introduced from Java 7. So allowed digits are only 0 and 1. In this case, the literal should be prefixed with 0b. Either 0b or 0 capital B. No problem. Okay, both are same. Fine. It should prefix with 0b. So for example, see, int x is equal to 0b10. So it is in which form now? It is in binary form. Binary form. Hope this thing is clear to you. Binary. Fine. So these all are four forms we have seen to represent what? Integral literals. So by default, every integral literal is of int type. This point you should know. See, by default, every integral literal is of which type? Int type. We can specify explicitly as long type by suffixing literal with L or capital L. Fine. For example, let me show you one thing. Here, int x is equal to 10. So by default, every integral literal is of which type? Int type. So it is int type. This is valid? Yeah, 100% valid. Now see, long L is equal to 10L. 10L. I'm suffixing this 10 with L. It means it is of what type now? It is of long type. I'm trying to assign the long type of value in long type of variable. So this is also 100% fine, right? Now, see here. What you are doing? Int x is equal to 10L. It is of which type now? Long type, right? Long type. And the long type of value you are trying to assign into int type of variable. Is it going to work, do you think? No, you will get compile time error. You will get what? Compile time error here. What is that compile time error? You will get what? Possible lossy precision. Or let me see what is the compile time error. Okay, so one thing is clear. You will get what here? Compile time error, that is something like lossy conversion. Fine, lossy conversion. If you want to see, let me show you this thing. We have to create one program. So what we can do, hold on, where is the notepad? We have to open the notepad first. We have to open the notepad first. So open the notepad. I want to write the program in notepad. Take one class, public class. We are learning what? Literal concept, right? So literal application Fine. Inside this class, take the main method, because main method is the starting point of any program. Public static void main string array args. Okay, do along with me so it is easy for you to understand the concepts. Now what we have to see, I have int type of variable. I am trying to store 10L, means long type of data. Save this with the same name, literal application dot java. Now save this, and you have to go to that location where you have saved this. So here it is, right? Open the command prompt here, cmd. Now run, try to compile this file. So java c, what was the file name? Literal application dot java. Hit enter. See, possible lossy conversion, right? From long to int. This is the error, right? So you may write this error also in your notes. It is good. So possible lossy conversion. What is this? Possible lossy conversion. Clear? Now let's see the next. See, long L is equal to 10. So by default, we have not suffixed this 10 with small l or capital L. So it is what type? It is of int type. So int type of value you can store in long type. No problem at all, right? If you want to see, let me show you this thing. Okay, let me show you this thing. Wait a second. Okay, so why I'm saying this? Tell me the size of this int. Tell me the size of this int. We have covered in the last lecture int data type. The size is what? 4 bytes, right? And long, talking about the long size is what? 8 bytes. 8 bytes. Don't you think 8 bytes are sufficient to store 4 bytes of data? That is the reason it is 100% valid. It will work. It will 100% work. If you want to see, let me show you. So remove this L. What I'm trying to do, I have taken one long variable, long L, save this, go to the command prompt, compile this. See, compiled fine. Run this. Literal application. Java literal application. Enter. Ran fine. Okay, compiled fine. Ran fine. No issue at all. So this is what the concept. Okay, so remember this point. By default, every integral literal is of int type. Fine. So actually we don't have any concept like byte or short literal. Okay, we don't have any concept like byte or short literals, short type literals. We don't have such thing here. Make this thing clear. So next we have what? Floating point literals. So floating point literals is of type float. If it ends with the letter capital F or small f, otherwise its type is double, and it can optionally end with the letter D or small d. Talking about in simple words, see, a floating point literal is of the type float if it ends with the letter F or small f. Fine. Otherwise, its type is what? Double. We will see this thing. Hold on. You will understand this point clearly. No problem. So, and the another thing. All floating point literals are by default of which type? Double type. This is the point I have covered in the last lecture also. So, for example, I have this floating point literal 10.4. So see, what is the first point? If it ends with the capital F or small f. See here, there is no capital F, no small small f. So it is of what type? Double type. If you want to make as a float, then you have to write like this: 10.4 f or you have to write like this 10.4 f, then only it will considered as what type? Float type. Float type. Otherwise, by default, it is of what type? Double type. Now clear? Fine. For example, let's see some example. So float. Let me write here float, and let me write here double. Double. Okay. And let's see the example now. So tell me, what is the size of this float data type? In the last lecture we have covered that is 4 bytes, right? And what is the size of double data type? That is what? 8 bytes. 8 bytes. So you have to take this thing into the consideration now. Fine. You have to remember this thing. So for example, in the first example, see, float f is equal to 123.456. See, I have not what suffix this value with capital F or small f. So by default it is of what type? Double type. It is of what type? Double type. Right? And see here what I'm trying to do. I'm trying to assign the double type of value into float type of variable. It means I am trying to assign 8 bytes into 4 bytes. Right? So is it possible to do this? No, you will get what? Compile time error. You will get compile time error. What is that compile time error? Same loss. If you want, you can take this. See, same error you will get. Possible lossy conversion from double to float. If you want to see, let me show you first here. Everything you should do in a practical way. F is equal to 123.456. Okay, save this. Go to the CMD, run the command of compilation again. See, what is the error here? Possible lossy conversion from double to float, incompatible type. Fine. So here you will get compile time error, that is possible lossy conversion. Fine. Now second example, float f is equal to 123.456 f. This time f is there at the end. It means this is of what type? Float type of value. So float type of value we can assign to the float type of variable. No issue at all. It is 100% valid. Clear? The next example, double d is equal to 143.564. So okay, if f or capital F is not there at the end, it means it is of double type only, because by default all the floating point literals are of double type. So it is of double type. So what I'm doing, I'm trying to assign the double type of value into double type of variable. It is 100% valid. Next, double d is equal to 143.654 capital D. It's optional. If you want, you can give capital D or small d. If you don't want, leave it as it is. It is considered as double only. So if this d is present here, it means double type. So same thing. Double type of value I am assigning to double type of variable. It is 100% valid. Now the next example. Float f is equal to 143.654d means double type. Double type I am trying to assign to the float type of variable, means double value I am assigning to the float type of variable. What I will get? I will get compile time error. What is that compile time error? Same, possible lossy conversion. Fine. This much is clear. Now let's see the next point. Next is Boolean literal. So what is Boolean literal? The only allowed values are true and false. True and false. For example, Boolean b is equal to true. It is 100% valid. Fine. But if I'm writing Boolean b is equal to 0, it is invalid. You will get the compile time error. Why? Let me show you this thing. See here. Boolean b is equal to 0. I think I have already covered this example in the last lecture. See, int cannot be converted to Boolean, incompatible type, right? You will get here compile time error. Why? Because see, Boolean will only accept this small true and small false. Okay, it is not going to. It is not like a C language where 0 means false and 1 means true. The concept is completely different in Java. Fine. So you will get the compile time error. It is treating this 0 as an int type value. Int type value. How can you store the int type of value into the Boolean type of variable? Not possible. That is the reason you are getting the compile time error. And what is that compile time error? Incompatible type int cannot be converted to Boolean. Now let's see the next example. Boolean b is equal to true where t is capital. So you know what? You will get error here again, compile time error. And I have covered this in the last lecture. What is the example? This example, okay, that what you will get in the output. See, you will get compile time error. Why? Because it will treat this true as a variable, as a variable. Okay, and compiler will search for this variable. Where is this true variable? It will not able to find out this variable, then it will give you an compile time error. If you want to see, let me show you. Boolean be is equal to true. Now go here, compile. See, error, cannot find symbol. Boolean b is equal to true. Symbol variable true. Location class literal application. It means it is treating this true as a what variable, and it is trying to search for this variable, but it is not able to find this variable, right? That is why it is throwing this error. Cannot find symbol. Boolean b is equal to true. Symbol variable true. Location is class literal application. Fine. And the last, Boolean b is equal to, in the double quotes I am passing this true. Whatever thing is in double quotes is of what type? String type. How can you assign a string type of value to the Boolean type of variable? You will again get what? Compile time error here. Invalid. Is it clear? I think this is pretty much clear to you. Now let's see another, that is character literal. So the single character placed inside single quotes is considered as character literal. For example, like this, a single character inside single quotes is called as character literal. So all character literals are of which type? Char type. This is char type of data, right? So all character literals are of char type. Example, we have char ch is equal to, in the single quotes we have a. It is 100% valid, right? Now char ch is equal to a. I'm just passing here what? A. Do you think it is valid? It is valid? No, it is not valid. Why? Because single quotes are missing. Invalid. Next, char ch is equal to, I'm passing this a into double quotes. So it will treat this a as a string type of value. How can you assign a string type of value into the character type of variable? Means char type of variable. Again, it is invalid. You will get compile time error here. Fine. Next, see, char ch is equal to, in the single quotes you are passing two values, that is a and b. It is also not allowed. What is the rule? The single character placed inside single quotes is called character literal. So you will get again what here? It is invalid. You will get compile time error. Now the next, char ch is equal to single quote. See, space is there, then a is there. So in single quotes we can place either single space or one character, and you are placing both the things, space also and one character also. Then again in this case also it is invalid. You will get compile time error. Remember this thing. If you want to check, you can check. Okay, let me check. So note, in single quotes we can either place single space or one character. So same example here we can practice this thing. So char ch is equal to, the second example I am taking, where it is I'm taking only a without single quotes. So let me see this. CLS. Okay. Now I'm trying to compile this application. Compilation done. See, It is treating this a as a variable and it is looking for this variable. That is the reason you are getting here compile time error. So this is clear. I mentioned here you will get here what compile time error. What is that compile time error? You can note down from here properly if you are making notes. So the next example, char ch is equal to double quotes, within double quotes I am passing a. Now compile. See, this time string cannot be converted to char because the a is in double quotes. That's why it is considering it as a string type of value. And how can you assign a string type of value to the char directly? Not possible, right? It is, and that is the reason you are getting this compile time error. That is, string cannot be converted to char. Next example. So within single quotes, I'm passing a and b. See now, compile this. See, again you are getting compile time errors because it is expecting only one value inside the single quotes. Okay, so this is the compile time error. Now the next thing, what was the last case? I was taking one space then a. Go and compile this. See, again same error, right? Same type of error. So you will get compile time error in this case also. Hope this thing is clear to you. In single quotes, we can place either single space or one character. Remember this point. Next. So you can also, we can also, specify char literal as integral literal, which represents Unicode value of the character. For example, I can write char ch is equal to 97. And if I will print this ch, I will get a small a because small a character equivalent Unicode is 97. Am I right? Last lecture also we have seen. So what are the possible ways? Hold on. Okay, so this is clear. This is perfectly valid. So this is perfectly valid. And one more thing is what? We can also specify what? This integral literal in decimal form or binary form or octal form or hexadecimal form, right? But the allowed range is what? But the allowed range is 0 to 65, 0 to 65535. Fine. So this in the second example, what I'm doing, I'm just writing this in hexadecimal form. Fine. So this is also perfectly valid. No doubt in this. Okay. And this is what octal form. So it is also perfectly valid because 0 is there prefixed with 0. So it is perfectly valid, right? You can do this in the notepad. Practice this thing. Now this one. Char ch is equal to 65,535. So allowed value is 0 to 65,535. So this is also valid. Now char ch is equal to 65,536. Okay, but the allowed value is max is 65,535. So you will get what? Compile time here, error here. It is invalid. You will get compile time error like possible lossy conversion. Possible lossy conversion. Is it clear? Now see, every escape character is a valid char literal. We will cover this point, don't worry. Just remember right now that every escape character is a valid char literal. Now the next literal is what? String literals. So string literals are nothing but the characters placed inside double quotes is considered as string literals. In double quotes, we can place 0 to n number of characters. For example, string s is equal to, in the double quotes, I have written my name, that is Naveen. It is 100% valid. It is what? It is what? String type of value I am trying to assign to string type of variable. It is 100% valid. Fine. Now let's see the next. So this all are what? Escape characters, and every escape character is what? what we have seen, every escape character is of char literal, is a valid char literal. Fine. So for example, we have escape character like um, you know backward slash n, backward slash t, backward slash r, b, backward slash f, backward slash single quote, backward slash what is this, double quote, and two backward slashes, right, backslashes. So I have described the meaning of each and everything here, like backward slash n means new line. It means insert a new line in the text at this point, wherever I have used this. Okay, insert a new line. Wherever I have insert this t, then insert a tab in the text at this point. Then we have this carriage return. Insert a carriage return in the text at this point. If I'm using this r, then insert a backspace in the text at this point wherever I have used this b, backslash b. Okay, and form feed, insert a form feed in the text at this point wherever I have used this backslash f, for example, right? Same for the single quotes, double quotes. If you want to insert a single quote character in the text, so you have to use this backslash and then this single quotes. Fine. For the double quotes, if you want to insert double quotes, then backslash double quotes. If you want to insert a backslash character in the text, then backslash and then again one backslash. Remember this, right? For example, see here, system.out.println c shade, okay, see backslash and then I am giving this double quotes hello, then backslash double quotes. So how it will print? It will print like, you know what, let me go to this and let me show you this thing. System.out.println, what I'm doing, see said backslash double quotes hello, then again backslash double quotes to me, to me. Save this, go to this, compile fine, run this Java literal application. See, now in the text this double quotes got inserted. She said hello to me and hello is in double quotes. So that is the use of escape character here, right? I hope this thing is pretty much clear to you. And same for this. If I want to insert this single quotes here, so this is what, backslash then single quote symbol. Fine. This will not come. This backslash will not come. You can see here. See, backslash gone. Only this double quote will come. So I think this much is pretty much clear to you. Fine. The next. So this concept got introduced in Java SE7, means Java 7, underscores in numeric literals. So in Java SE7 and later, we can use underscore symbol between digits of numeric literals. For instance, if your code contains numbers with many digits, you can use an underscore character to separate digits in group of 3, similar to how you would use a punctuation mark like comma or space or what as a separator. Like we usually write 10,000 like this using this comma separator. So if you have if you have more number of digits, then you can separate that using what, underscore. That is what this concept is explaining here. Fine. For example, see double d is equal to 789,344.987. So I want to what I want to do, I want to separate this digits in a group. So I have used this 7 then underscore then 89 then underscore then 344.9 underscore 8 underscore 7. You know, after the compilation, what will happen? It will form again like this. You know, it is only to maintain the code and to improve the readability of the code, to improve the readability. For example, see here, long credit card number. So credit card number I have grouped into the group. This is what? Group of four digits. Group of 4 digits. So readability is easy here, right? By the help of what? Underscore symbols. Readability is easy here. So at the time of compilation, this underscore symbol will be removed automatically. Hence, after compilation, the above code lines will be like this. See, double is equal to this and long credit card number is equal to this after the compilation. So this is only for your convenience so that the readability is easy. The code maintainability is easy in this case. Fine, it is easy to read these things. Is it clear? Now see, note, any number of underscore characters are allowed between digits in numeric literals. But there are certain rules. You can place underscores only between digits. Remember this point, only between digits. You cannot place underscores in the following places like at the beginning or end of a number, or adjacent to a decimal point in a floating point literal, or prior to F or L suffix, or in position where a string of digits is expected. For example, see here, float pi is equal to 3 underscore 0.14157f. It is invalid. Why? Cannot put underscore adjacent to a decimal point. The rule. Okay. This rule you should remember. The second point. Adjacent to a decimal point in a floating point literal. Not allowed. And this is the decimal point, and you are placing this underscore just before that. It is invalid. Same here. At the end. You can't place at the end of the number. It is also invalid. Next. See, at the starting of the number you are placing, it is also invalid. Now, long credit card. See, what I have said, prior to F or L suffix not allowed. So, see, before L I am using this underscore. It is not allowed. Invalid. Fine. So this is all what the cases we have covered in the literals. I hope everything is pretty much clear to you. So thanks for watching this video. And thanks for your valuable time. Please subscribe our channel for further updates.